Hello YouTubers, I've got a circuit I want to share with you. This is for the delayed lens effect transformer, otherwise known as the delayed conduction transformer. Other people working on this have said it can be up to 200% efficient, and others quote much higher numbers. I think the difficulty lies with the complexity of getting it working on a specific transformer. It can be quite difficult. So what we want to do is we've got our primary on the transformer. We have two secondaries on the transformer. We want to take our input square wave to the transformer. We want to observe that, or whatever it happens to look like, on the secondary, and then we want to short it out on the secondary and see it reflected in secondary number 2, where we see something like a triangular waveform, and then we want to extract the energy from this side, and that will be providing energy to your load through somewhat of a magnetic resonance effect rather than being reflected from the primary, thus to a point eliminating Len's law. But it's not really doing that. But anyway, the effect is fairly similar. So what we want to do is we want to read the voltage across the primary, which in the case of my transformer looks quite ugly, depending on the loading and whatnot. I feed in the square wave to the primary, and then that's what I read on the primary with the oscilloscope. So what I want to do is use an op-amp to clean that wave right up and to make it adjustable so I can do whatever I want with it. And then I want to feed in a small delay for the delayed conduction. I want to do this. So I want to adjust the time between the input trigger and my trigger. So I need that to be adjustable, that time there. And then the rest of this wave that I will use to bounce the voltage from the secondary to the number 2 secondary using a transistor. This pulse will trigger the transistor to do that. So I want to adjust this pulse time also. Now looking at it initially, I go, well, that's probably not too difficult. You've got one timed bit that you need to be adjustable. Well, I can use a 555 timer for that. And you've got another timed section. Well, I can probably use a 555 timer for that as well. And then to clean up the signal, well, we can use an op-amp, throw in a couple of transistors, and probably presto. That's what I thought. And basically, I'm right. However, the intervening 3 days told me that there's quite a few difficulties involved in doing that. The first one is that in order to make it adjustable in every way, what you want to do is not have a 555 timer putting out its usual string of pulses. What you want to do, or what I want to do, is use them in one-shot mode. So you press a button, it gives out one pulse. Press another button, it gives out another pulse. And that will keep them synchronized. So I'm going to use the input trigger signal to trigger a 555 timer to give me that small pulse delay there. And then I can use the output from the first 555 timer to trigger another one, and then that will create a time delay for the second trigger. Great. So you can now just completely ignore that mess. Now this is where the problem bit comes in. The output I'm getting from my op-amp, although it's nice and clean and easy to work with, does have a few difficulties. If I use that to trigger my first 555 with the single shot mode, my timer will turn on and it will not turn off again, despite me setting the right capacitor. Because when you put your finger down on the button for the 555 single shot, although if I take my finger off instantly, just tap it on and off again, I will get the delay that I asked for, just a very short pulse. However, if I leave my finger on the button for the whole duration of the input pulse, which is what you'd expect to happen, then my timer won't work. It won't turn off. It's impossible to turn off before the input pulse turns off. Right, that's the first difficulty. So what I would like to do from my op amp is, instead of having a nice square wave, what I would like is something like that, just a single line, just so it triggers my timer and then turns off and then allows my timer to run out. But we can't do that. We can do that in many ways, but we choose not to because that is unnecessarily complicated. So what we do is have two 555 timers, both one-shot mode, and both triggered from the same source, the op amp. This will be our normal one that we want our aspirational short wave to come from, and this second one will have a much longer wave that will be used to disable the op amp. So, and this one has a capacitor on the input and it creates a very slight delay, so this one turns on ever so slightly before this one. So our op amp signal turns on, triggers the first 555. Now then our 555 runs out for a small timer, and then because the second 555 is on a slight delay, that comes on here and stays on for a longer period, and that shorts out the op amp until the end of that pulse, and then you can start again. So that allows us to turn our op amp, our original input pulse, into a synchronized timed pulse. And I'll turn over the page and show you just how to do that in practical terms. Okay, so, excuse me, just clear my throat. So, what we have is the input pulse to our transformer. As we know, that is not a thing of beauty. And then that will switch into our op amp. Great. And then we have our two 555 timers on the previous page that we're going to completely ignore. The second one is there just as convenient to make the first one give us what we want, which is a very short pulse to cause a delay, and that will appear there, directly in line with the rise time of our input. So we have a delay. Now what we will need to do is trigger the rest of our circuit, which is the pulse we actually want to use to short the secondary. So we want to trigger that second pulse from the full time of our first 555 timer. And to do that, we need an inverter circuit. And I'll show you what that is. We've got our two thingamadoobies, our primaries, in phase with our short pulses. Now, these short pulses will be fed into a transistor, thusly straight into the base, just like that. Now, we have a collector over here, let's say, with a resistor on it. It's a positive. So 7 days a week, 365 days a year, we're going to see a positive voltage if we read there on our oscilloscope. And this of course goes to ground. So the exception to this is when the trigger pulse goes on, which is only for a very short cycle. So every time the trigger pulse goes on, this positive resistor, which is about 10k, gets shorted to ground. So at the same point here, we see that go to 0 volts. So if we put our oscilloscope on there, we get an inverted signal. We don't get this signal here. We get our permanently on positive, except for a short negative while the transistor's on. And that is what we came from. So what we can do is use this positive short duty cycle signal to get inverted upside down into that signal. So that means the start of our positive signal at the bottom, measured here, is positive with a delay on it. So we're going to use this long duty cycle positive for the rest of our circuit to trigger the timing on the transformer. So we've now created our delay and we can move forward with the project. Now that delay, or rather that long duty cycle positive, because you're now familiar with the problems of triggering a one-shot mode with a long positive, we're going to do something slightly different for the next output pulse. We're going to drive that long positive into pin 8 of the next 555 timer, which is going to provide the positive voltage rail. So for a long duty cycle, our 555 turns on, and pin 2 is connected up there. So the whole time that the 555 timer turns on is permanently pinned to pin 2, thereby not doing anything. However, the very second it turns on, it has to charge the capacitor. So the minute we turn it on, we can create, if that's the input to the power, the capacitor actually takes a little while to charge, and we can adjust the time that is with the size of the capacitor, or adjusting the variable resistor between pins 7 and 8. So we can turn that signal into something like that, and they're not in line. Despite my terrible penmanship, I do apologize. So the output from this one, pin 3, can be used to drive the transistor which shorts the secondary. So there's our primary, we've got our op amp, the small delay timing on the first page, and then the inverted signal there drives this transistor up here, and the rise time on there will give us an on time, because that's reading a 0 volt signal, because that will translate into 0 volts on pin 2 whilst it's still low. So this one will start on, the output from this one will start on and last until the capacitor is charged, so something like that. So we can adjust the the delay before the pulse begins and the time of the pulse itself. Right, and that is the essence of the circuit. So, now that we've got that out of the way, I can set the camera down and show you the actual circuit in operation. And my dinner, obviously. So, I'm going to get a bit more light on it. Right, this is the second 555 timer. And here's the effect on the transformer. The yellow very ugly wave is obviously what I'm reading across the primary of the transformer. And we're going to short part of the secondary to the other part of the secondary using the wave on pin 2, which has that very convenient delay on it. Probably best to have a look like that. Okay, I'm just going to pause that. Now, as mentioned, because I've got two 555 timers, one convenient aspect to this circuit is, I should say, this guy here is the op amp. Here is the first timer that creates the short pulse, and the second timer that creates the long pulse that allows the first one to be possible. And that's the transistor that shorts the pin 2s to ground. So, what I've done is these two can be adjusted simultaneously with the variable resistor simply by putting one side of the pot to ground, to positive, and one each to each end of the transistor. And I'll twiddle that and demonstrate the result. So if I turn that pot, I better make it a little easier to see. But yeah, conveniently allows us, if we can adjust both at the same time, that is the, sorry, I picked up the wrong pot. The one I'm holding with my hand now and turning is going to the output pulse. So this timer will ultimately trigger the shorting transistor across the secondary. And by turning that one there, it gives you full adjustability for how long the pulse lasts. And then you can adjust the time before the pulse kicks in with the other one. And I'm going to try and hold the camera still. It's only actually going to make a very slight difference. It only adjusts the duty cycle by 5% or so, which is really all we need, because I've got exactly the right size capacitor in there, because we only want a slight delay. So yep, that's the essence of how it works. The next video will be demonstrating it actually working. So yeah, thanks to all the viewers. Here's the circuit shared, and I'll insert an image of the final diagram. Thanks for watching.